For decades, an astronomical theory dominated our understanding of the solar system, the idea that we live in the shadow of a massive protector. This vacuum cleaner hypothesis suggests that Jupiter's enormous gravity acts as a shield, intercepting or ejecting rogue comets before they can threaten the inner planets. It is a comforting model. It implies that Earth's biosphere has been allowed to prosper because a big brother planet is actively clearing the neighborhood of debris. This idea became so entrenched in planetary science that it remained the standard assumption for years before researchers actually ran the simulations to verify if it was true. In July 1994, humanity finally witnessed this theory in action when a fragmented comet named Shoemaker-Levy 9 hurtled toward the gas giant. Fragments of the comet slammed into Jupiter's atmosphere at 35 miles per second, lofting superheated plumes of gas into the stratosphere. The collisions left massive, dark scars across Jupiter's southern hemisphere. Some of these impact sites were wider than the entire Earth. To observers at the time, this looked like definitive proof of Jupiter's role as a shield. The planet had quite literally taken a bullet for us. However, physical evidence on our own planet, like the mile-wide meteor crater in Arizona, suggests that catastrophic impacts are not just a Jovian phenomenon. Witnessing the sheer scale of the Jovian hits revealed that massive, world-altering collisions are an active, present-day threat in our solar system. Modern orbital simulations reveal a dual nature to Jupiter's gravitational influence. The shield mechanic is real, but limited. Jupiter deflects long-period comets entering from the edge of the solar system. But for asteroids and short-period comets, the giant acts as a slingshot, altering their orbits until they cross the paths of the inner planets. In 1770, Comet Lexell grazed Earth by just 1,000,000 miles. This near miss happened only because Jupiter had diverted the comet from its original orbit 3 years earlier, aiming it directly at us. Jupiter functions as an active participant in our danger, stripping objects of their stable orbits and redirecting them toward the inner solar system. This table from a series of n-body simulations shows how Jupiter's mass affects the number of times Earth gets hit. With our current Jupiter at 1.00 mass, Earth receives 239 impacts. If removed entirely at 0.00 mass, impacts drop to 181. The math suggests that for short-period objects, Earth would actually be safer if a Jupiter-sized planet were not there at all. If Jupiter is a modern hazard, why do researchers claim humanity wouldn't exist without it? The true answer lies billions of years in the past, during the violent formation of the early solar system. Jupiter's early growth carved physical gaps in this swirling disk of gas and dust. This acted as a barrier, preventing the rocky material that formed Earth from spiraling into the sun. At the same time, Jupiter's gravity flung icy material inward from the outer system, delivering the water and volatile molecules required for life. Jupiter did act as our protector, but that protective work was completed during the birth of the planets. Today, Jupiter is just as likely to hurl a rock at us as it is to block one. The 1994 Shoemaker-Levy 9 spectacle served as the catalyst for the modern planetary defense movement. Witnessing the devastation on Jupiter's surface led Congress to mandate that NASA find and track at least 90% of the large asteroids in our neighborhood. We are now developing the technology to intercept and deflect these threats ourselves, rather than relying on gravitational chance. We have moved past the era of the cosmic vacuum cleaner myth. For our continued survival, the only true protector we can rely on is our own ability